Good afternoon. How's everybody doing? Good, I hope. I want you to know that if you think I'm going to do any cartwheels, probably not. You don't want to see this do a cartwheel, just saying. So I want to talk a little bit about software-defined networking, and I want to do that in the context of my experience. So back in 2006, I was an end user, and we started building out our first Ethernet plant floor controls network. So we really went cold turkey Ethernet in 2006. And if I look at the challenges we had then versus what's available today from a technology perspective, particularly in the case of SDN, I'm going to try to kind of compare and contrast the differences. So for those of you who are not maybe as familiar with SDN as others, it really is the same network that everything you have runs on today. The only difference is how the network is managed. All right, standard IEEE 802.network. So the software-defined networking kind of started back in the 10, 12 years ago, let's say, and it was pretty predominant in the cloud space. And at the time, it was really a paradigm shift in how they were going to do things. What they needed is more flexibility. They needed more capability. They didn't have the luxury of going out and physically rewiring, rerouting, and doing all the things that we might do with a network today. So this idea of software-defined networking came into being. So it's really, today, is a paradigm shift in the OT space. So if you look at operational technology or controls networks, they're pretty, depending on the company, they're pretty traditional. Some companies, they're crazy and they use rings, which I'm actually a proponent of rings. Star topologies. What you don't see are things like typically like a mesh, for example. But in the world of SDN, a mesh is fine. You cannot mess up the network. It's kind of like money in the checking account. As long as there's checks in the books, you can write checks because you've always got money. In the world of SDN, you can really plug things in however makes sense to your environment and what you're trying to accomplish, and it will work. You're not constrained by some of the things we see today in a typical OT network. So, as I said, most of my career was an end user. And in 2006, we really started down the road towards Ethernet IP as a field bus at the time. Where was it when I needed it, right? We really break it down from an end user's perspective in manufacturing. At least we were discrete manufacturing, so there's a lot of other pieces of manufacturing, process and lots of things. But generally speaking, we broke it down into design. So we have to design the system, design the network, build our standards. Deploying that at an OEM or a machine builder who's building our equipment, right? They've got 40 weeks to build a $10 million line, and there's 60 PLCs, 60 switches, and that's really the challenge was how do we do that? The next piece is how do we manage it once we have it? Right? Once it lands on my floor, it's a different environment. The OEM floor, if you guys have ever done that, is kind of a free-for-all because things are in a constant state of flux when you're building equipment. At least on the discrete side, they're moving equipment around, they're rebalancing the line, so it's a bit of a challenge to try to put anything in place from a security posture because if you set that up, the next day, that whole end of the line has moved, shifted, changed, equipment's no longer there, it's now down here, so it becomes a big challenge, and how do you do that? And of course, the security, right? How do you secure the system? How do you secure the equipment? I'll tell you, in 2006, we weren't really thinking about security in 2006. It wasn't something we really started looking at until probably 2009 or 2010 when we started developing some solutions for securing our plant floor networks. And of course, visibility wasn't really a big thing for us. Now, I will tell you that if you've ever worked with, show of hands, who's like an end user machine builder in here or worked with machine builders or had equipment built for them? So you know that about the time you deliver it to the plant, you have 6 months for those drawings to be useless, right? Because as soon as it hits the plant floor, they change. And you don't know what's there. You don't know where it's plugged in. I can remember troubleshooting systems in Mexico, and you're listening to what they're telling you. You're looking at what they're saying is the case. They've even sent you a chicken scratch on paper, and there's no physical way in the sun the network is wired that way and working the way that it is. It's just not possible. Right? So visibility was a huge challenge, but we didn't have an answer. There really wasn't anything back in that time frame that let us do that. So what I want to do is kind of go through the pieces of each of these sections and talk about what was our challenge or our question and how would that be answered today in a software-defined network, okay? Design. So when we designed it, what topology we use? Well, do we use a star? Do we use a ring? Do we want dual uplinks? Do we want to dual home the switches so that we have redundancy, right? How do we configure that? Whose switches are we using? Nice thing about SDN is it doesn't matter. Use the topology that makes sense for you. Flat network? Well, we'll talk a little bit more about that, right? Because we've been preaching for years that flat networks are evil, but maybe that's not necessarily the case. Maybe that's a byproduct of the technology and the approach we were taking. What about spanning trees? Well, we ended up at the time using rapid spanning tree, right? Because if an engineer or an electrician plugged the cables into the wrong place in the network and created a loop, the whole line would go down. So we needed something in 06 that would keep that from happening. And to give you an idea in 06 how new this was, we actually put a product on one of our lines and we couldn't figure out why it wasn't working until we realized that it only had an ARP cache of 8. Right? So that's how new this stuff was. When you connected I/O to your line, you might be lucky enough to be able to set a gateway address without it imploding. All right? That day, he's nodding his head, he's been there, right? So that's, when I say we didn't have the tools, not only did we not have the tools, most of the vendors didn't have a real clue what an Ethernet field bus device looked like. It was, oh, we did it with ControlNet, now we've got a TCP/IP stack from the same guy. Say, hey, we're Ethernet, right? And that was really what it was for the first couple of years. How about IGMP? Oh, we struggled with IGMP, right? Because back in the day, there was a lot more multicasting in 06 than there is today, right? Particularly in the world of Ethernet IP. So, you know, my little plug there, live long and multicast, right? What matters is how do you control who the querier is and where it is? We found at times that the querier was all the way across the plant, right? Because our IT guys, where we touched bases with them, put in a nice layer 3 routing system, and it was crazy where sometimes this stuff would end up, right? What else do we have to worry about? VLANs. We struggled with this idea of VLANs, not because we didn't think it was a good idea. We couldn't figure out how to get electricians and plant OT personnel who didn't understand what an IP address was to understand what a VLAN was, right? I mean, I remember having conversations with guys that would get an OEM and bring in a piece of equipment, and it'd have a 3-dimensional array in the PLC ladder logic, and I would look at them like, are you for real? Are you seriously expecting us as a customer to support that? You have any idea? I mean, nobody in my plant's going to get that, right? Well, the same thing is true here. VLANs. So VLANs, obviously we know segmentation is necessary. I would argue that, I would not argue, and I would expect no one in here would argue that the segmentation is necessary. Anybody in here think segmentation's a bad idea? Right? But by the same token, you can go way overboard. We have a customer today has no less than 14 VLANs in every switch in their plant floor in every panel. And their number one source of downtime is related to VLANs and people trying to understand them, how they work, what to plug into what port, what's trunked where, right? It's a struggle. And I've heard stories, well, yeah, they took the line down, they were working on a couple of panels, the electricians unplugged all the Ethernet cables from this one to the front of the switch. I said, well, they got the prints out, right, and followed the prints because they were all clearly identified what each cable was. It was tagged properly and you're laughing, right? It's all tagged properly, and we know where they're going to plug them back in, so everything should come up working. Zero chance that ever happened, right? If it did happen, it was time to go get a beer and call it a day because it was like, you know, it was the unicorn of your day. So what about VLANs? Well, what if you don't need them? In the world of software-defined networking, the network is micro-segmented. It is infinitely more segmented than anything you could do with VLANs. And you don't have to manage it. It takes care of it for you. It is device-centric, meaning I want this PLC to talk to that robot over Ethernet IP only. And what you get is basically an isolated communication that is allowing Ethernet IP between those two devices only, all right? So the idea of VLANs is really unnecessary in the world of SDN. In fact, it overcomplicates things because the network or the fabric of the network in the case of SDN takes care of that for you. And I can tell you right now when I talk to customers and I say, what's your biggest pain points? Spanning trees, VLANs, and they give me, and I'm like, well, what if you could just get rid of them? What if what they intended to do is not wrong? Absolutely. We just agreed that segmentation is critical, right? But if we could do it better and more granularly, better and more granular should be better, right? How about what switch brand should we use? Oh, we struggled over this. Struggled, right? Do we use Belden? Do we use, Rockwell at the time didn't have a switch. So we went to our Rockwell partners and said, hey, what switch should we use? And they said, Belden. And I said, are you guys ever going to come up with your own switch line? No. So we spent 8 months designing it, testing it, building it all out, and introducing the Stratic switch, right? So we stayed with Belden because we were there, because they were really the player at the time. In the world of SDN, it doesn't matter. As long as the switch supports the standard, it doesn't matter. You can use a Cisco 9300. You could use a Dynix 8-port switch. You could use SEL, Allied Telesys. The list goes on. And it's growing more and more rapidly in the OT space. There's lots of SDN switches in the enterprise-grade switches. It's growing rapidly in the OT space. But, what do I do about my line in Brazil? Maybe I can't get Belden down there as easily as I can get it here. What about the line in Thailand, China? Right? I've got these all over the world, and I want a standard, but if it costs me 3 times as much to buy that switch, that's kind of painful, right? And I'm not necessarily willing to do that. Also, if you've ever managed stores in a plant, and if you don't know what stores is, that's where people go to get stuff when it breaks on the floor and they got to put new stuff out. Stores. Stores is part number based. So when they go to stores, they say, I need this part number, all right? And if stores doesn't have that part number, you're toast, right? You have a serious downtime problem. If you didn't have to worry about the switch because all you needed was a switch that supported the standard and you could source that locally and it was whatever was convenient, you and I would probably never mix switches on a single system right now if we have the choice, right? I wouldn't put Stratix and Belden and Moxa and Dynix and all these other switches on the same network. I would try to keep them the same. In the world of SDN, it doesn't matter because the magic of the network and the management of the network does not take place in the switch. I will never run around to every switch to make a configuration change, right? Grandmaster clocks, who would have thought that was a problem? Well, we used to do something called an NVH machine. Anybody ever heard of an NVH machine? It's noise, vibration, and harshness. We built axles. Some of those axles were 1,500 pounds. We would spin those axles at 5,000 to 8,000 RPM, and we would apply drag to them to simulate dragging on the vehicle, dragging climbing a hill, or coasting, going down the hill, dragging on it that way. You did not want to not know where your clock was, apparently. We learned this the hard way, right? If the Grandmaster clock was the little bitty PLC 27 hops away through, any more than 7 and on a non-1588 switch, any more than 7 hops and the disparity in time syncing becomes too great, you were toast. So all of a sudden, what we found out was, hey, we actually have to care about where this Grandmaster clock is because when we're doing motion, it's critical, right? In the world of SDN, I have absolute control over my Grandmaster clocks. I can determine who, what, and where are the clocks. I could have one clock. I could have a clock in every single station. I can let only that PLC talk to these servos with 1588 PTP. Therefore, I know who the election will be. The other problem was, unless you really know how to preload the election process, it's Mac-based. So if I put a Mac in that's newer than the Mac I had, the Grandmaster clock is changing, right? Anybody run into that before? He's nodding his head over here. He knows. Dave, you probably have. It can be painful, but now I have absolute control over that, okay? Layer 2 or layer 3 switches. Well, I just need switches to support SDN, right? I don't need anything more than a layer 2 switch because everything is micro-segmented and there's no routing taking place. It doesn't route, doesn't need to route. So the way I want to do this, though, is at the end of each one of these sections, I want to talk a little bit about what are the challenges that SDN maybe wouldn't be, where I might still have a bit of a difficulty. This will be very dependent upon the SDN controller that you utilize, right? Because some will handle this, some will not. But what if you plug into the enterprise network where you want to send data up and there's 3 VLANs trunked on that connection? What if they're using PVST plus because you're connecting to a catalyst switch, right? So you have to be aware of that. And some controllers will handle that very well. They'll auto-identify the VLANs. They'll let you even talk to a device down in the SDN network that's on a VLAN, even though the SDN network itself could care less about the VLAN. It just helps facilitate that because they understand what's the truth of the matter is you're not going to rip and replace all of your switches in your enterprise to make them SDN today, right? It's just not going to happen. So they have to talk. They have to be friendly. Dual port devices. Right? Again, when you're looking at software-defined networks, make sure that the controller understands the difference in a dual-port device because it's both a switch and a device. So if your controller thinks it's a switch, it's not a device. If your controller thinks it's a device, it's not a switch. So you have to be cognizant of some of those things that are a little bit different, right? I've got a customer today who he uses DLR as his ring network, and then he puts a bunch of 2-port RFIDs in between all the switches on that DLR ring network, okay? That's a bit of a challenge, but if you're working with the right controller, that problem is solved. Beacons, beacons, beacons. SDN works like this. When a packet comes into a switch, the switch says, do I have a flow? That's that communication between 2 devices. Do I have a flow that says this packet is okay because it's intended for that device on Ethernet IP, and I have a flow already that says that's cool? If so, switch just lets it go. If not, that very first packet is sent to the controller. The controller evaluates its policies and says, do I have a policy that says that device can talk to that device over Ethernet IP? I do. Send the flow to the switch writes the flow, controller is no longer necessary. I could turn the controller off. I could reboot the switch 500 times. Next time it comes up, if that device tries to talk to that device, the switch is going to say, no problem, you're good, okay? Well, if you have something like a beacon, Anybody not familiar with DLR? You guys kind of know what DLR is, right? Device level ring in the world of Ethernet IP. So it beacons, and the beacons are about a 50 millisecond rotation around the network. Well, if you think about what I just said and how the switch works, if you're sending a packet up to the switch every 50 milliseconds from 150 devices on the network, the controller is like, I said no, right? Wait a minute, it's back. I said no, still back. I still said no. But you start doing some funky things with, I had a customer hit line speed because he plugged it into an enterprise network that had so absolute much traffic that it literally took his link to line speed. And he couldn't figure out why the controller wasn't responding. I'm like, well, you're at line speed and you're not doing anything but asking it, should I let this thing talk? So there's this concept of block flows. So when you look at a controller, make sure the controller does this thing called block flows, because what's going to be critical is the second that first DLR beacon gets up there, the controller says, nope, I never want to see this again, writes a block flow to the switch. The switch gets the packet on ingress next time, throws it away. And it'll just keep throwing it away until the controller says, yeah, I want to see those again, okay? Again, so that's kind of a difference, beacons. And how flat is too flat? I love this discussion. Anybody in here heard anybody recently say, you know, the flatter your network is, the easier it is to manage and the more secure you are? I can't remember the last time I heard that. Did you say you've heard that? Okay, were they right? Maybe? Possibly. I'll give you the possibly is correct. So if you look at what we've done with segmentation of networks, if you look at the whole VLAN concept, if you look at the whole hierarchies that we've built and put in place, from a physical perspective, you know, flat versus not flat, largely it was to support the technology that we use to help us segment and manage the network. It's not because we all necessarily thought that was the right way to go. It just made sense. In the world of SDN, it doesn't matter. You can have as hierarchical a network as you want. You can have as flat a network as you want. In fact, I would argue that if I had a great big flat network, but it was an SDN network, it would be A, more secure, and B, easier to manage. Right? And if you're like me, you've been in traditional networking for as long as traditional networking has been around, there are concepts in SDN that you will melt your head because they're contrary to everything you've ever heard, right? But it's important to step back and go, that really, I get it, right? But I still have customers today that say, all right, well, how do I control this port? Well, that port doesn't matter. In the world of SDN, ports are irrelevant. It's the two devices. Can they talk to each other, right? Are they allowed to talk to each other? And by what means are they allowed to talk? So this whole idea of ACLs, port ACLs, don't need it, okay? That concept doesn't apply here. All right, so deployment. We used to have to configure all of our switches for our OEMs. That was painful. So we bought them and configured them and delivered them, because the first few times we tried to do it when we let the customer configure our switches, didn't work out exactly as we'd hoped. So we started doing that, right? Well, what if I don't have to do that? What if I can put my SDN controller in learn mode and just let it learn the traffic, write its own flows and its own policies based on what it sees on the shop floor at the OEM? I'm a lot less concerned about security on the OEM floor, still concerned, but less concerned. So if I could tell this thing, learn the traffic, learn what devices are allowed to talk to each other, write the policies to allow that, and then I can go peel that stuff out that I don't want later, that's a great solution, because then I don't have to worry about configuring switches. They literally power them in, plug them up, and you're pretty much go. Okay? Controller takes care of the rest. I get a lot of OEMs that don't understand networks and security. It doesn't matter, right? We can put the controller in learn mode, and it'll do what it needs to do to let whoever talk to whatever, wherever on the network. Okay? We used to have to be on hand. I used to get zinged by my machine builders and equipment builders. They would say, you have exactly 3 days to get out here and reconfigure this, or we're going to charge you a big boatload of money because you've stopped our ability to build your machine. This goes away, right? So deployment, what are the SDN challenges? You have to be able to adopt a switch, which means you tell the switch, this is your controller, you talk to nobody else ever, you take no directions, no configuration from anything else ever, period. Okay? It's a pretty simple process, but it's different than what we have to do today, right? When the equipment is moved, you should take a look at the rules and decide what you want to keep, what you want to get rid of, and the policies. And when you connect it to the enterprise network, you don't just literally plug everything in, which we don't do today. I mean, if you just walk in and start willy-nilly plugging things in from your controls network to your enterprise network, they really don't like a lot of the stuff that we bounce around enterprise networks, okay? So managing it. How do I make changes 60 switches? I don't. I make one change and it applies to 60 switches. I make a change and I say all HMIs can talk to all PLCs in zone 2 over Ethernet IP. I'm done. All PLCs anywhere in my network, even if I move them around 27 times today, will only be able to talk to all the PLCs in that zone over that protocol, period. Doesn't matter where they go, okay? Can't fat finger changes like that. I mean, I can tell you I've tried to configure, and my guys used to go out and try to configure like minor changes to something. We'll miss it on 4 of the operations, and the guys on 3rd shift tonight are gonna have to figure out why it's not running or working. You don't need to back up your switches. That was a huge problem for us, right? The controller knows what the switch is supposed to do, so if you plug in a new switch, the controller goes, configuration goes to the switch, and you're done. Right. Training plant staff. This is super easy. I can literally teach somebody in maintenance who's not a network person. It takes me about 15 minutes to show them how to manage it. Now again, some of the stuff I talk about is specific to the type of controller or whose controller you're using and how much thought they've given to the OT space. Because there's lots of SDN controllers that are not OT specific or don't take into consideration OT capabilities, staffing, things of that nature. Knowing what's on the network when deployed and being accurate. I think we talked about this a few minutes ago, right? I used to say 6 months. 6 months. By the time 6 months has escaped or passed after I've deployed equipment to one of my facilities globally, the drawings are no longer accurate. And how accurate or not accurate they would be depends upon where you are and what was going on, but they were never the same. Nobody ever redlined a drawing, so I never knew what was out there. In the world of SDN, you have real-time asset inventory. I know everything that's on the network, where it's on the network, when it's on the network, what port it's on the network, of what switch it's on the network, and I will see it immediately if it moves. Not in an hour, not after we've rescanned the network, because SDN is the network fabric, I will see it when it moves in nearly real time, okay? I will see it when it tries to talk a new protocol. It will tell me, this device on this port of this switch just tried to talk Profinet to this device on this port of this switch. Traffic was blocked. right? Out-of-date drawings, doesn't matter. You get a nice topology that's real view of what your network looks like. Controlling supplier access is huge, right? We didn't know how to keep people out. How do I keep them from uploading our proprietary SCADA PLC stuff? If I can plug them into the network anywhere, they can get there, right? Beautiful thing about SDN is that guy can only get to his equipment and only over Ethernet IP. He can't even ping it if you don't let him. He also can't go to the web page on that if you don't let him, right? So you have, and it won't matter where on your network he plugs in, he can only get to his device. He can only see his device, okay? We tried with written policy to do stuff. Right, yeah. Written policy is great, and I would never argue that you shouldn't have it. I will argue that by the time it hits the plant floor, the likelihood that it's followed is slimmer than we would like, and that's just the way it is, okay? In general, switches and stores, talked about that a little bit. You know, how do I keep personnel from plugging stuff into the wrong place at the wrong time, either creating loops? You can't create a loop in an SDN network. Won't allow it. It calculates the fastest path between 2 points, but it will not let you do things like create loops. So SDN Challenges, it's not designed to control user-specific access. You have tools that you like for that you use for that. They still work. They're still very valuable. But SDN is specifically not designed to control user access, okay? It's designed to control device, protocol, that type of thing. If there's a tool you like that sits on your network today that helps you control user access, use it. It'll work just fine, okay? It's a different way to manage the network, but it's a traditional network. How do I keep people from getting our IP? Don't let them get to the equipment that's not theirs. How do I keep them off the network when they don't belong there? Don't let them on the network. They're gonna plug their laptop into any port of any switch, and if they're not allowed on the network, that packet goes right out the window. They can't get there from here. But I'll get an immediate notification telling me somebody on this port of this switch with this laptop just plugged into this, right? How do I know when a supplier is on my network and where they're connected? I will know, again, where they plugged in, what they're doing, and what protocols they're trying to use. All right. How do I know what protocols are on my network? You will know in nearly real time when something is on your network. If something new shows up, you will know in nearly real time, okay? You have that visibility into your network. How do I keep people from taking it down? By creating loops? We talked about that, right? Don't let them create loops. How do I keep them? You see, I get off topic. I get way ahead of my slides sometimes. I even forget I have a clicker periodically. So, fortunately, I've only got about another 2 hours, so we'll get through all this. I realize I'm between you and beer and sunshine, so I'll try to keep it down to less than 2 hours. You know, the mind twist, it requires you to think differently about the network, because it eliminates a lot of the things that we struggle with today when you deploy the network. And we can have that conversation, but I will tell you that you know, even myself, I'll start thinking about something in 25 years of networking, start saying, well, I shouldn't, and you're like, no, I don't have to do it that way, right? Can a physical network be more segmented than a network is not? A physically flat network? Absolutely. I can absolutely be vastly more segmented than anything you can create with VLANs. I won't even argue it. I have a customer right now who just deployed their first line. There are 3,500 flows in a given switch. That means they have created, and this is a horrible way to describe it, there are 3,500 point-to-point communications between devices and protocols on their network, and it's managing every one of those as an individual conversation. You will never do that with VLANs. Not only would it be obscenely difficult to manage and configure, it would be, you wouldn't be able to do it. It'd just be painful. The network is device-centric. It's not switch or port-centric. That's a big mind change, right? We think today port-centric, right? SDN is not a silver bullet. It does not solve all problems of all things. What it does is lay a tremendous foundation at the network fabric layer that you can build upon to mitigate those risks that you are concerned with, right? Everybody knows that the amount of security you need depends on the amount of risk you're willing to live with, right? But if you start with a solid foundation, you get visibility, you get firewall in every port of every switch, even east to west across a single switch. You can't do that today with much, not very easily. If you start with SDN and you do it and you put it in play in the OT space, making sure it's a controller that understands what the differences in the OT space are, you'll find that it makes a huge difference, right? I keep pushing the laser pointer, which I was forewarned to never push. So this is a great time for questions. Again, I'm Jeff with Dynex, and we offer, of course, the products that are up there, including we work with a partner company called Veracity, who has an SDN controller for the OT space. So I'm happy to talk about that stuff with anybody afterwards or later. You can get a hold of me at that. But are there any questions? Please use the microphone if so.
Yeah, so how do you deal, the SDN is concerned with device-to-device flows.
Yes.
How do you deal with device trust? And then another thing you said, like, how do you know the device that's purporting to be the device that you've established a flow for is the device that you're expecting? And then another thing you said was that all these switches need to be layer 2, but my experience on the enterprise SDN side is that the vendors tend to pack the SDN interfaces up in the higher tier layer 3 software packages, so you end up having to pay for it anyway. So is that different in the OT space? Or?
Let me answer your second question first, because this is short of the two answers. It doesn't have to be layer 2, doesn't have to be layer 3, whatever supports the standard, okay?
Oh, that was the key question. What is the standard? What standard is emerging right now?
So the current standard is a technology called OpenFlow, okay? There are other standards that are coming along, but unfortunately some of those standards, at least from the OT perspective, are very silicon focused. So unless you want to put a 240 gigabit chipset in your 16-port switch in a control panel and pay the extra $4,000 for it, probably not going to happen. To your other question, and again, this is going to be controller specific or centric, right? So in the case of the controller that I'm most familiar with, we fingerprint the devices. So let's take, for example, it's a Rockwell device. I plug it into the network. So the first thing we see is an ARP, we see a MAC, we see all the normal stuff. Then the next thing we're going to do is we're going to do a SIP identity request. And we're going to say, who are you? We're going to get back product codes. We're going to get back serial numbers. We're going to get firmware revisions. We're going to get a couple other pieces of data. We fingerprint and use all of that. So if I unplug that device from the network and I plug it in somewhere else and we see it come back on the network, we're going to say, this is all the same, we're good. If I see that the product code is 13, it used to be 7, but the MAC and everything else is the same, that device will be immediately quarantined. So we take a deeper dive, and again, that's kind of one of the OT specific pieces of it, is we take a deeper dive on the device to understand how to fingerprint it. Did that answer your question? Okay, great. Yes, sir.
So first of all, thanks for the talk. It's awesome. I'm super familiar with SDNs from back in the day. The RoofNet to MIT to Meraki to Cisco and Nasira. I have a complex question, so I'm trying to get through this. But the OpenFlow protocol, there's lots of research that was happening in the early days. Mm-hmm. In the current state with cloud native solutions, you've got like traffic and core DNS.
Yep.
Not necessarily, it's the total polar opposite of the OT space.
Right.
There's things like AWS, Greengrass,
Yep.
and lots of the businesses headed or already in the cloud.
Yep.
Where do you see the convergence of things, and you may not be familiar with like traffic and core DNS, I'm not sure, but there's a convergence at some point where you've had this early consolidation of M&A, right?
Yep.
In the tech. You now have cloud and lots of consolidation M&A. Yep. You've got physical layer, and you've got cloud, and you've got things like Kubernetes and stuff in between with essentially SDNs, but they're not SDNs, they're part of cloud native stuff.
Yeah.
Where do you see that mold going, and is there other standards besides OpenFlow that people should be looking at and monitoring?
Great question. That would probably take me about 15 minutes to answer correctly. The short answer is OpenFlow is the technology that's working today, and it works on the plant floor and in the OT space. Makes a lot of sense there. A lot of these other technologies that are rolling through the enterprise are based on that. At least they cover it up really nicely, but they won't tell you it's there. There are other technologies like P4. If you're familiar with P4 technology, it's not the same. OpenFlow is an application layer protocol. P4 is literally much lower than that. It's a programming level. You could literally create a switch, a communication between devices with OpenFlow because you wrote it in P4. So the convergence is going to be more gradual. The biggest problem from an OT perspective is people are scared to put their safety off the floor.
Yeah, and that's where you asked about a layer 1, question earlier. Yeah. I was thinking that like the idea of like if you secure the edge with kind of like a CASB, a cloud access security broker, but at the edge using SDN, you could flatten everything out potentially and have the right VLANs that trunk up.
Absolutely.
So
No argument or discussion there at all. Yes, sir.
Two questions. Would you argue rip and replace or gradually moving into it?
That's a really good question, and we work with a lot of customers, and I'll give you all the perspectives that I've heard. And surprisingly to me, it's changed in the last year and a half to 2 years, probably last year. So my initial thought was, and as an end user who's deployed thousands and thousands and thousands of switches in production networks around the world, I can't imagine ripping and replacing, right? So my answer to that would be, well, you can literally we always had an aggregate switch at the top of our network, where all of our rings came back to this. If I make that SDN, I get a tremendous amount of benefit by replacing that one aggregate switch with an SDN switch, because I can still manage traffic up and down and in between and across that switch. So that's one answer. The thing that surprises me the most, and I had this conversation with the head of OT cybersecurity for one of our bigger customers. It's one of the automotives, the big three, and it's not GM or Ford. I can't really say who, but it's not GM or Ford. I said, what are your thoughts? And the answer was, well, when I look at some of the monitoring tools and software I'm looking to put in right now and the cost that's going to incur, I got no problem spending a couple $100,000 to replace switches. And so that was the answer, and I was like, wow, I'm surprised. One of our other big customers had to replace all of their Cisco IE4000s in a plant because they were trying to get their ICE install to work, and Cisco said, you guys need to use this version of firmware. It's not available on that platform. So they literally spent 4 months and replaced every single switch across the facility. And the reason for that is visibility and control and security is exponentially more important today than it was. So that cost is amazing to me that, her answer was, I'll happily spend a couple $100,000 on switches if that gives me what you're giving me, which is control and visibility, instead of me spending $3 million across a couple of plants for some software. The cool thing is, depending on the SDN controller again, and you may get the plug for me in there someplace, if your controller supports things like per switch learning mode and network learning mode and has lots of tools that allow you to do that, I could literally, if you could wire up all the switches, I could convert an entire plant in a half an hour. Because I'm just going to put the controllers in learn mode, and when it tries to come up and things start trying to talk, the controller's going to say, no problem, no problem, no problem, no problem, just go, talk. And they'll be right back to where they were with their existing switches. At that point, they can say, though, I don't like this telnet stuff. I don't like this FTP. I didn't even know I had FTP on my network. Don't want that. And as soon as they start doing that, it literally in nearly real time starts, I'm a controls guy, so nearly real time to me means something. I had some guys try to sell me software a few years ago, and they said, oh, it's real time. I said, it is? They said, yeah. I said, well, how long does it take to update? They said, well, 3 to 8 seconds. I went, dude, that isn't even close to nearly real time in the controls world. I said, we think microseconds, milliseconds at best. That's nearly real time. So that's the answer I would give you. It's there are ways to do it without ripping and replacing and still significantly elevating the control and visibility, but some customers are surprising me and just simply saying, I want the control, I want visibility. I'm not opposed to doing that.
What about mixed environments, right? So most logically, you won't rip and replace.
Yep.
And most likely, you would have different segments that will be on different technology for some time.
Yep.
But until then, you won't get the full benefit of SDN, meaning no loops, no visibility, all those stuff.
Yeah, so I can't control what isn't the SDN network, but I can control ingress and egress into it and out of it from a traditional network. Even by VLAN, I can connect to stuff that's on maybe it's using PVST and it has VLANs 201, 301, and 401. Because there are controllers out there that are smart enough to identify all that, and even though they don't care about VLANs, they know how to work with them. So it makes it very easy, and again, that's our experience in the OT space, right? We know how that works. That gives you the ability to get started and ease into it and drastically, over time, increase your security posture without a lot of risk, because risk is the key in manufacturing. We used to have a line that built axles, built a new axle every 9 seconds. It was 60% of the company's revenue. You shut that line down, you didn't even want to be in the plant. If that line shut down, you didn't want to be in the plant, right? So uptime, mitigating risk is key. So what we've tried to do is, and what SDN does, helps you mitigate that risk, but still start moving to a technology. But dropping in that one aggregate switch, like I said, it's going to drastically elevate your security posture with literally replacing out a single aggregate switch. Okay? And I'd be happy, I've only got a fixed amount of time, but I'd be happy to talk to anybody about that over time. Find me on LinkedIn, find me at my email address. We can talk about it. I can give you what my other perspectives are, and if you're interested into technology, I can certainly help you get pointed in the right direction. Any other questions?
More of one final comment.
Yeah.
When you say a person not familiar with IP or VLAN or trunking is capable of doing an SDN network, I don't believe you.
Fair enough. I'd be happy to prove it to you. I love to put my money where my mouth is.
Just a quick question.
Yeah.
Is this primarily just in the discrete world, or have you actually seen this actually work with DCS vendors like a Delta V or Experian?
If it can plug into an Ethernet network, it works.
Okay.
There's literally, again, as I said in the onset of this, and that's a great question, this is nothing more than the network you have today. We're simply changing how it's managed. Okay? We're adding some automation to it. Okay? And some intelligence. Yeah, you have to go there, though.
It's more related to impacts in the actual infrastructure. Let's say I work for a global company and I have been traveling for 8 years for segmenting all the networks. And suddenly comes up SDN networks. And we have this discussion on the table. So which are the real impacts from moving from a nice OT network segmentation to SDN networks? Do I have benefits, or this is something for a greenfield project?
Oh, absolutely there are benefits, right? You get infinitely better segmentation, significantly less complex configurations, a central point of management for all of those switches. You can make decisions like all of the devices in zone 2 can talk over Ethernet IP to everything in zone 3, or you can say things like all the PLCs in zone 2 can talk to the HMIs in zone 3 over Ethernet IP, but nothing else. So the management becomes significantly easier, and the overall complexity of the system becomes vastly. I had a customer of mine right now at one of the big 3, wasn't Ford or Chrysler, who said, I told him initially, I said, if it takes me more than 15 minutes to show you how to manage your network, I've messed up somewhere in what we've built. And he was doing a podcast with me a couple of months later, and the podcaster asked him a question, and he said, well, Jeff told me at one point it would take me 15 minutes to learn how to manage my network, and he lied. So, of course, we're in a podcast. I about melted. I'm thinking, oh, here it comes. Here's the 50-pound hammer. He said, it took me about 10. Okay, so saved me big. Any other questions before I let you guys get out to the sunshine and the cabana sessions? Great questions, by the way. Like I said, if you have more, I'm happy to talk about it. I'll be around for the next couple days. Find me. And to the gentleman who doesn't believe me, I love that, and I would be happy to give you a different perspective. All right, thanks, guys.